Let's go ahead and fix an error with our one-way analysis of variance that we did for the lizard snout vent lengths. I've rerun the analysis here and I've corrected an error with regards to how the variables were defined. So here to begin with, I've already put the R code in just to save a little time. I've cleared the memory, so rm list equals ls. And then I've defined my data set SVL data, and I'm then using the read.csv command to do that, and then file.choose with header equals t. So that's just as we did before. I then attached the data set using attach SVL data. And then I view the data set, and you need to make sure that you use capital VIEW, so capital V and then lowercase IEW. If you don't, you get an error statement. So I'm asking it to view the SVL data, and when you do that, then the data shows up in this window up here. And if you look at this, you'll notice right away that the column name for species is now in the correct format, not the way it was in our previous edition. And that's because I've saved it as a regular sort of CSV file in Microsoft without any of the weird sort of other configurations that are available. So this is just the standard default CSV format for Microsoft. Very good. So then once I have viewed those data, then I ask for the structure, and here's where the problem shows up. Because if you look at this, there's my label for species, and it's treated as interval data, so it's not it's not being treated as a factor. It's being treated as sort of an integer, so it's as a continuous variable. So it's assuming that there is a species 4003.1, 4003.2, and so on, and I obviously don't have that. So then there's the snout vent length and so on. So the way to solve that problem is then simply to define species as a factor, and we do that here with the next command. So SVL data, $species, and then I'm assigning to that variable species, I'm converting it to a factor, so as factor, so SVL data, $species. Then let's go ahead and do a box plot, and when we do that, so we're going to do snout vent length as a function of species, and now species is defined as a factor. And I've x label equals species and y label equals SVL, and you can look at the diagram over here, and that's exactly as it should look, right? So now we have the species label and the snout vent length label. Then I'm going to create a new sort of file, my svl.mod. So that's where I'm going to put my model, and we're, just as we did before, we're going to use the linear model option. So SVL as a function of species, and then I define data equals SVL data. And then I ask it to give me the ANOVA model, and I've made a mistake here. Instead of typing ANOVA, I've typed ANOV, and that clearly is not an available function in RStudio, at least not at this moment. So let's fix that. We type in ANOVA svl.mod, and that then returns to us the ANOVA table. And the first thing you'll notice is that this ANOVA table is different. The degrees of freedom associated with the model is now 6. Sure, that's because I have 7 species here in the analysis. So 7 minus 1 is 6. In the previous version that we had up, the degrees of freedom associated with the model was just 1. And that's because it was treating it as a regression problem rather than as an analysis variance. You'll notice too, this table differs a little bit from the tables we've used in class in that it doesn't give you the totals. So it doesn't give you the total degrees of freedom or the total sums of squares or the total mean squares, and that's fine. The degrees of freedom are additive and the sums of squares are additive, so we don't really have to have that, although in a publication you would certainly want to provide that. The other thing that this doesn't provide us with is the is the coefficient of determination. We've not talked about that yet in class, but we will do that very shortly. And I will show you how to compute the coefficient of determination. And you'll notice that the model is significant at the 0.05 level. I mean, you could make the argument that it's significant at the 0.001 level or whatever, but that's silly. All we care about is it's significant at the 0.05 level, yes or no, and it is. Very good. So please substitute this code for the code that we used previously. The previous code is wrong. This one has been corrected. Very good. See you guys next time.